Hi, welcome. This is going to be what I'm going to call BEC 101. And the idea behind the video is explain a little bit about BECs and how you would use them and hook them up. Now, there are a couple different kinds of BECs, and as a matter of fact, I think the term BEC for some of them really shouldn't be used. What BEC stands for is Battery Eliminator Circuit. Okay, before regulators and all that kind of stuff, most models were flown with a 4.8 volt 2-cell battery which hooked to a switch harness, and then one of the leads plugged into the receiver and provided power to the receiver on the red and the black, or I'll get into these lines in a little bit, but on the power lines. Okay, so the idea behind a BEC is, hey, we already got a flight battery, so let's eliminate the weight of the receiver battery, because we already have one that powers our motor, and figure out a way to hook it up, and thus the term BEC. Now, don't confuse that with, even though this is called a BEC, this is really a linear regulator. It really, in my opinion, doesn't eliminate a battery, which is what BEC stands for, Battery Eliminator Circuit. For this one comes off the T-Rex 600 electric, and the input, the maximum input is a 2S LiPo, or 7.6 volt is what it says here. So 7.6 volt, and that's its input. Well, if we take our speed control, and this is where our big pack hooks up, right? And on a T-Rex 600, that would be a 6S pack. We can't hook this here, okay, because it'll be too much voltage for this. So this needs its own separate LiPo 2S battery. This really is not a battery eliminator circuit. What it is what's called as a linear regulator. A linear regulator usually has a specific input voltage, and it regulates to a specific output voltage. In this case, this one outputs 6 volts on the black and red wires that plug into your receiver, okay? And it takes this 7.6 volts input and regulates it down to the 6 volts. So this really is a regulator. If you go to places like Duralite and whatnot, who actually calls them regulators, that's what they're called. Another prime example of a regulator was in the old days. This is where 6-volt systems come from a little bit, or where they originated, was some people wanted more power out of their servos, and servos were being made to support 6 volts, so they'd use a 5-cell NiCad, which actually puts out more than 6 volts fully charged. Well, they'd hook this to a regulator, okay, and then the regulator would output a constant 6 volt to your receiver. So this is really called a regulator, not a BEC, okay, even though it is, say, BEC. Okay, so be aware of that. Understand the difference between what a regulator does and a BEC. What a BEC does is usually, let's take a look at this little one I have here. This one says 3 amp max, 5 amps surge. It supports 2 to 5S LiPo, which means I can hook up a 2-cell LiPo, 3-cell LiPo, 4-cell LiPo, 5-cell LiPo. Okay, so it has a large voltage range. This one also is selectable whether I want 5 volt or 6 volt BEC regulated output, okay? So a BEC still does do some regulation. It still tries to regulate that voltage for you to the receiver so it doesn't go above or below either 6 volts or 5 volts, okay? But the difference is, because this is a switching type BEC, the difference is I can hook this to my connector here, where my main battery that runs my motor plugs in, as long as the number of cells I'm running is supported by the BEC. In this case, I can only go up to a 5-cell with this BEC, so I can go 2 to 5. So for instance, on a T-Rex 450, if I soldered these when I soldered on the speed control wires, then I plug my 3S pack in here, I now have a separate BEC. I'll talk about eliminating the speed controller BEC in a little bit. So anyway, how do you hook up a BEC that is a true battery eliminator? It eliminates the need for an extra battery. Well, as I said, you can solder the red and black on here when you solder on your speed control to your Dean's connector. Okay, another way is you could use a separate connector and make a jumper here in the middle, another Dean's. This taps into there. That way you can unplug the BEC if you want. So you'd put another Dean's on here, and male to female, and then have your battery plug in. Another way to do it could be done that way. Easiest way I find is just go ahead and solder them on. You can always cut the heat shrink and desolder if you ever need to want to remove it. No big deal. Okay, so that covers the input side of a BEC, all right? Again, the key is make sure it supports how many cells you're going to run off your speed control. So now let's talk about the other end of a BEC and speed control and that kind of thing. Let's take a look at a receiver here for a minute. This one happens to be more than 6 channels, and I'll talk about some tips with some 6 channels here in a minute. But the bottom line is, if you look at any servo or device that plugs into a channel on the receiver, they all have 3 wires. Here's a servo, for instance. Let's talk about what these 3 wires are. And the colors vary from vendor to vendor. Black is ground, red is always positive, and white is the signal. This is the signal wire that the receiver sends a pulse train out on that tells the device to do something. Move a servo, speed up the throttle on a speed control, adjust gyro gain, you know, that kind of thing. Okay? So the signal wire is an output of the receiver. The black and the red from a BEC is an input, but it's an output that powers your servos. I'll talk about that here and how a receiver is now wired. So if we look at how a plug plugs in, and usually they're keyed so you can't mess them up, make sure on your receiver, get that plugged in there, make sure on your receiver you pay attention to the signal, which is the square on there, and the plus and minus, and you get them plugged in properly. Okay, this receiver clearly shows you that the white wire should go toward the bottom. Then you got the black and red. Now let me explain something here. On all receivers, the black lines are all in a row. Notice that, and the red lines are all in a row, and of course the signal lines are all in a row. These pins are actually soldered to what's called as a bus bar in the receiver. All the blacks are soldered together, and all the reds are soldered together. So what does that mean? Well, it means is that if I'm running a more than 6-channel receiver on a helicopter, because you need 6 channels on a helicopter, aileron, elevator, throttle, gyro gain, rudder, and pitch. So if you've got a 6-channel receiver, you only have 6 channels. But on a receiver that has more channels, all you need to do to power it from your BEC now is plug it in an open channel. For instance, on this one, I could plug it into aux 4. All right, and because remember what I said is that these are all connected together. So I'm inputting power on ground or I'm inputting a connection on ground and power in on red. And guess what? Now that power is going to be available to anything else that plugs in here. Servos, gyros, speed controllers, anything. Okay? So that's how a BEC powers the receiver and all of the equipment. It's because of these lines are all tied on one thing. So if you've got a more than 6-channel receiver, just plug the BEC in an open channel. If you don't, and you only have a 6-channel receiver, you won't have any holes, extra holes available. So let me give you a tip on how to do that. If you're using a 401 or many of the other gyros, you'll notice the gain lead only has 1 wire in it, 1 yellow wire. Okay? What you can do is just simply take an X-Acto knife and lift these little tabs right here where these pins are. These lock the pins in, okay? Lift it up a little bit, and then you'll be able to pull the wire out of the connector. Do that to both the black and the red, and then go to your, let's pretend this is the gyro gain wire, would only have 1 yellow line there. There won't be a black and a red. You simply insert your pins in your gyro lead, and now when you plug your gyro gain line in, the BEC will now be connected to your gyro gain line, and when you plug it in, it will power the receiver and everything else because of that common bus that I just explained about. All right, so that's a trick for doing it, on a 6-channel receiver if you have a gyro that doesn't use those power pins for the gain. Another way to do it would be to simply cut the connector off and tap into these wires by cutting it off, soldering them, and resoldering them all and heat shrinking them. So you could do that from, say, your speed control. Okay, that way your BEC and your speed control are tied together. All right? So that's basically it. That would be another way to do it, a little more difficult. Okay, so now, some speed controls have a BEC built in. For instance, this Align one has a BEC built in. So what it's doing is the signal out for throttle comes on the signal line, and that tells the speed control to speed up or slow down the motor. And the black and red are actually powering the receiver. Okay, so power is going to be put in, and of course when we plug into this bus bar, it's going to apply power to the receiver and all the other pins. But what happens when you want to use a separate BEC with a speed control that has a built-in BEC? Well, here's what you do. Once again, you lift this little tab here for the red wire. Be careful not to break it off. You only need to lift a little bit, and you pull the red wire out, okay? Put some heat shrink on here, roll it back, wrap it with tape or another piece of heat shrink. The bottom line is you want this pin covered up so it doesn't touch or short anything. Remember, it's got power on it because your BEC, your speed control has a BEC in it. All right, so you want to pull that back. If you don't care to ever use it again, you can just cut the wire and you're done. All right, so then what you need to do is, now that this is eliminated, if you're running more than a 6-channel, once again, you can plug this into any channel. It'll now power everything, and it won't argue with the power from the BEC and the speed control. The other way to do it would be to go ahead and pull the red pin out on the BEC and insert it in the hole you just pulled out for the speed control, but then you also need to cut the black wire and solder the black wire in. Okay, so you can, again, use your 401 empty holes, or you can do what I just said here and use the and tie the BEC into this connector. So red wire from the BEC would go in the one you just pulled out, and you tap into the black wire. Now here's the deal. You can't just remove this black wire as well, and here's why. Any device that has any servo, speed control, anything, this signal, if it's expecting to receive a signal on the signal wire, it needs a point of reference for the ground. Well, remember, just because we eliminated the BEC out of the speed control, we still need this signal to tell the speed control when we increase throttle or decrease to raise or lower the motor, right? So that signal. Well, the signal needs a ground reference. Without this black wire, it will lose its ground reference and won't work or be sketchy, okay? It might work if you did it, but don't trust it. It's basically, this device now has a floating ground and doesn't really have a point of reference. You need to have that black wire if there's a signal wire involved. Any device that plugs in here is going to have a signal wire, except, of course, a BEC. A BEC does not have a signal wire. Okay, so that kind of describes linear regulators, BECs, how to eliminate BECs and speed controls and add your own, how to lift the pins and what the wires are all about, you know, this whole bus bar on the receivers and how that works and why you can use any slot to power the receiver and the devices that connect to it. And so that's basically it. I hope this was helpful to you, and enjoy.